Hello, in this presentation we're going to be talking about the calculation of the elasticity of demand. Last time we looked at elasticity in a more intuitive fashion, basically saying that if we graph the demand curve and we have a more flat demand curve, a more horizontal demand curve, we have a more elastic demand curve, such as the demand curve for pizza, in which case there's a lot of substitutes for pizza. We could substitute for something else. Therefore, we're looking at the relationship of a change in price. What will be the resulting change in quantity? If we change price, is there going to be a large or small change in quantity? In the case of pizza, given the fact that there's a lot of other fast food out there, if we change the price, it's possible that the quantity will change a lot, meaning it's more elastic, more kind of stretchy like a rubber band. The quantity changes a lot with a little force in terms of price. And we think about prescription drugs. If it's a drug that we really need, basically in order to stay alive or something like that, we can imagine the change in price having a very little change in terms of quantity usage. That will be graphed in a more vertical demand curve, meaning that the change in price here will result in a lesser change in terms of quantity. Now we're going to look at this numerically. We have to look at this numerically in terms of a formula. This will be our formula. So we have elasticity of demand. It's going to equal the change, the percentage change in quantity divided by the percentage change in price. That will be our formula if that formula results in a number that is greater than 1. So if elasticity calculation results in a number greater than 1, we're going to say it's elastic. If it results in a number that's going to be less than 1, it's going to be inelastic. And if it results in a number that is going to be equal to 1, it's going to be unit elastic. Now it's important to note when we do that calculation, it's always going to come out to be negative. So we don't really use the negative sign. We usually drop the negative sign. So when we say it's going to be greater than 1 or less than 1, we're really taking the absolute value. And if it's less than 1, meaning it's point something, it's less than 1 in terms of a decimal. If it's greater than 1, it's going to be 1 point something. It's going to be greater than 1 in that format, not in terms of a negative number versus a positive number. So in this case, the number that's going to be greater than 1, the elastic item will be the pizza. The inelastic would, in this case, be the prescription drugs, where the calculation is going to be less than 1. Now that we have defined the formula, we're going to make the formula a bit more complex. You can see that if we have the formula here, we see the percentage change in quantity divided by the percentage change in price. Now when we have the percentage change in something, we're trying to see how much something has increased or decreased on a percentage basis. For example, if we're talking about sales or something like that, if we had sales of $100 in the first month and then sales of $150 in the next month, and we're trying to figure out what the percentage increase was, we would take the change, which would be the 150 minus the 100, divided by the original number, divided by the original 100. That would be 50 divided by the original 100. We'd say it was a 50% increase. So if we have $100 in month 1, and we say there's a 50% increase, we would then end up being at 150. Then if we said that there was a 50% decrease from 150, intuitively we might think we should be back where we start at 100. But that's not the case. A 50% decrease would take us back to 75. So the fact that we cannot go directional wise and end up in the same area is a bit of a problem when we use this formula in some cases. In order to eliminate that type of problem, we use a midpoint formula, meaning the percentage change is going to be a little bit different than taking the change divided by the original number. Instead, we're going to take the change in Q divided by the average. So we're going to take the two quantity numbers, add them together, divide by 2. So it's a bit more complicated. It's not too bad once you do it a few times, a bit more complicated. Then we'll often see the formula written as we'll multiply it times 100. And then let's move the decimal over. And then we're going to divide that whole thing by the change in price over, obviously, again, the average change in price. So we're going to take the two numbers in price, add them together, and then divide by 2 to get the average. We could then multiply that by 100 to move the decimal over. Note, though, that the 100 is on both the top and the bottom. Therefore, we can cancel that out. So our formula can cancel that out, leaving us with our midpoint formula. So our midpoint formula, bit different than a percentage change formula, being the average on the denominator of these two calculations, leaving us with this here. So we're going to use this. We're going to have some examples in terms of this calculation. Here's going to be an example where we have an inelastic demand. We can see that it's going to be inelastic because it's more of a vertical line. This is going to be the numbers related to that graph. And we're going to assume that this is going to be an example closer to something like the prescription drug, where if the price changes, there's less of a change in terms of quantity. So if we plug these numbers into our formula, we're really going to plug the point in this yellow area. So this is going to be price on the left-hand side, quantity on the right-hand side. We're going to say that the change in quantity is going to be the 11 minus the 13. Notice I'm going from the second number minus the first number as long as we go the same way, meaning the second number minus the first number when we do the price as well. We should be okay. We're going to divide that by the average quantity. The average quantity being the 11 plus the 13 divided by 2. That will be the average of those two numbers. We're going to divide that entire thing divided by the change in price over here, which is going to be the 100 minus the 75 divided by the average price. Average is going to be the 100 plus the 75. We take that, we divide it by 2. If we do the math here, we'll simplify this down a bit. We're going to say that the 11 minus 13 equals negative 2. We're going to divide that by 11 plus 13 divided by 2. That will be the average of 12. Makes sense? 11, 13, average 12. We're going to divide that by the 100 minus 75 being the 25. Divide that by the average price. Average price 100 plus 75 divided by 2, giving us an average of 87.5. We simplify that down a bit further. 2 divided by 12. It's going to be 0.1667 about. I dropped the the negative sign at this point. Again, they're always going to be negative. We're really taking the absolute value and put the absolute values on there. You can put a negative sign in front of elasticity, but it doesn't really mean anything. That's why it's usually eliminated. So I'm eliminating it basically at this point, so be aware of that. We're dividing it by, then the 25 divided by the 87.5 gives us approximately 0.2857. Then the 0.1667 divided by the 0.2867 will then give us the 0.58. Since it's a point, it's less than 1. And therefore, we have something that's going to be less than 1 and inelastic, as we predicted, given the fact that we have a fairly vertical demand curve, given the fact of the type of product that's given for the example. Numerically, in order to have something be inelastic, this calculation needs to be less than 1. If we took a different set of numbers and we said, okay, we have something that looks more elastic in this case, we have a more horizontal demand curve, we have a different set of numbers, let's plug these numbers into the same formula. We're going to have the change in quantity in this time being 80 minus 120 divided by the average being the 80 plus the 120 divided by 2 in terms of quantity, dividing that entire thing by the change in price 125 minus 100 divided by the average price 125 plus 100 divided by 2. That then, I'm not going to go through the full calculation, but if we did the same type of calculation, we would then get to 1.87. Again, I dropped the negative sign. We're removing the negative sign. We're not saying it's greater or less than 1 because it's negative. It's either going to be less than 1 because it's point something or it's going to be 1 point something or something greater than 1. In this case, we got 1.81 greater than 1. Therefore, it's going to be elastic as we predicted, given the slope of the demand curve.